and just giving us a few more options. So if we're taking a look at two similar triangles and make sure they are similar, if we know that, then basically all the rest of these things also have to follow that same proportion. One of them is the perimeters of those triangles have to follow the same proportion. If the ratio is 1 to 3, the perimeters are going to have a ratio of 1 to 3. It has to follow. Okay, so perimeter is one you can put in that box. Another one is the corresponding altitudes. Because remember, how many altitudes does each triangle actually have? Each triangle actually has 3. So you have to make sure you match up the right altitude. It can't be just any one you want. It has to be the corresponding one. And altitude, again, is the one that hits at a right angle. All right, that's the one you want to look for there. Corresponding medians. Again, medians kind of the ones that hit the midpoint. But again, it has to be the same one in both triangles. And corresponding angle bisectors. So of those 4 segments we learned in, was that chapter 5, I believe? Which one is missing? Which one's not on there? Of the ones we learned, we've got altitude, median, angle bisector, and what was the other one? Perpendicular bisector. So perpendicular bisector, not on here. Some people make a note of it that way, but basically all the rest of them have to be good. And let's take a look as to what that really means. So I'm going to basically tell you that in the figure below, this is important here, because what's that little symbol right there mean again? That they are similar. Very good. So we're basically being told they are similar. And let's just fill in the information and see what we can do then. Well, DE, what have we got? 200. All right. EF is 300. FD is 250. And BC, where's that? There it is 600. It says then determine the perimeter of ABC. Well, what I just popped up on that last page is if the triangles are similar, the perimeters have to hold the same ratio. Okay. If we take a look at this one, well, obviously the way we're going to go is we're going to go 300 to 600 is probably the ratio we're going to start with. So 300 to 600 we know has to be true. Okay. So basically we went from small triangle to big triangle is one way you could look at it, right? So what we can do if we want to is just go ahead and find the perimeter of the smaller one and put it into our proportion. And what is the perimeter? We got 300, 200, and 250. So we're looking at, should that go on top or on bottom, the 750? Top, yeah, because that's the smaller one. And down here, well, we really don't have a variable in this problem, so you can make one if you want, and I think X is a pretty common way to start. Now, once again, some of you, I think, are not doing this yet. Save yourself some time. How can I save myself some time on this one? Well, you got 300 over 600. That reduces a lot. That reduces basically to 1/2, right? Does that save you quite a bit of time and all this work? Instead of sitting there on your calculator, maybe you miss a 0. Well, that's going to throw some things off if you miss a 0. So now basically all we have to do is take X times 1. Well, that's nice. That's just X. And then 2 times 750 is 1,500. Now, do we have a label on this one? No, we don't know if it's inches or meters or anything. But 1,500 is what? It's the perimeter of ABC. Would there have been anything wrong with going over here and just finding each side? Because what would side CA have been had you had to find it? 500, right? You could have done that, and this one down here, AB, would have been. Is it okay to do it that way and then add it up? That's fine. I'm trying to show you that maybe you could save yourself some time and just go with the perimeters. Okay? Or maybe I'll give you a problem where I give you the ratio, I give you the perimeter of one of them and nothing else. So that's what you might want to use that. But yeah, this one could have been done either way, and actually if you add those up, you do get 1,500. So that was the first one on there. Perimeter is good. All right. So again, we were told that they are similar. Which of the ones that were on that first page are we talking about? Are we talking about perimeter on this one? No. Which one's being used here? We go from vertex and perpendicular to the other side is altitude. Yes, CZ and GY are altitudes here, but they're supposed to hold the same proportion. Again, this is triangles. You have so much freedom here. You have to decide how you want to do it. A lot of the way we've been doing it is like this. 22.1 over x is kind of the way we've been doing it, left to right, because that seems like that's how we like to read and think. And if I set it up that way, I have to go 15.6 over 10.8. It's a little harder to see any reducing on this one, so you might just go ahead with the calculator on this. And so why don't you go ahead and solve this one? All right, let's see how you did on that. Well, if we're going to do it the way you've been taught, we'll probably take 22.1 times 10.8, and I'm guessing some of you are kind of going back to when you have easy ones like this, just do the cross multiply and divide, I'm guessing. Is that correct? That's how some of you are doing it? And if you did that, what do you find out for x? If you did cross multiply and divide, you get, now it does 15.3 is, does that seem logical? Over here was the side a little bit bigger than the altitude, and then same thing here. So does that seem like that works? Yeah. Now, is that the only way I could have set this one up, though? That's a very common way to do it. Would it have been okay to, say, do something like this? 15.6 over 22.1. Could I have started it that way? Yeah, but then how do you do the other one? Well, yeah, 10.8 over x. Do you end up multiplying the same stuff together that we did in the other one? Yeah. So again, triangle's kind of nice. Even if you're not 100% sure how to do it, you can almost kind of just guess your way through some of it. And most times get lucky. So the first one, perimeter, we had. The second one here was altitude. Well, what's this next one? That is the median. So this is supposed to work, right? And once again, are they corresponding medians is the question. Well, here they are sitting similar. Oh, we're looking pretty good. So here we go. How do you want to start this one? Anybody have a strategy they want to use? Maybe a little different? Maybe change it a little bit? I see a lot of people going like this, but let's change it up. We'll go 16 over 20 equals 12 over x. I think this is back to one of them. Why wouldn't you simplify it first? Why wouldn't you make life easier? The 16 over 20, let's make those numbers smaller. And what does that become? 16 over 20 becomes 4 over 5, right? So what do we got there going that way? We'll kind of go more the traditional method here. 60 equals 4x divided by 4. X is 15. In looking at it, does that make sense? Yeah. If you look at the other triangle, it's a little bigger on the bottom leg. Yeah, so that's definitely believable. Had we got something like 55, well, we should have been probably a little suspicious. So that's 3 out of the 4, leaving us with angle bisector. So an angle bisector in a triangle separates the opposite side into segments that have the exact same ratio as the other two sides. And we'll explain what that means in example 4 if that doesn't quite make sense. You could say it splits the side into the same ratio if you wanted to paraphrase. All right, now that you're done writing that, here, let's take a look. Well, here are the two sides, so that's basically the ratio you need to use. Those are the two sides that did not get split. So it'll be 18 over 24, and it's saying these two pieces, x and 9, have to follow the same ratio. Do you think it matters which one I write first? If I went 18 over 24, should I be careful? Yeah. So I should probably go x over 9 or 9 over x? X over 9. Follow the same pattern. Once again, let's take our time and let's reduce that 18 over 24. What can we do there? Well, we can at least take a 2 out, right? And so that becomes what, 9 over 12. Can we do any better? And take a what, a 3 out, and it becomes 3 over 4. Well, that makes life a little bit easier. So now we got 4x equals 27. Uh-oh. Well, that doesn't look very good. Can you do that? Well, yeah, just divide by 4. Do you think I'd be okay if you left it as 27 over 4? Yeah, I'm all right with that, but some of you probably like to see it a little bit different way. And how many times does 4 go in without going over? 6. So 6 and 3/4, because there's 3 left over. Now, if you put that in there, does that make sense if we put 6 and 3/4 back in here, or 6.75 for those of you that maybe went the other way? Does it make sense that this side up there is going to be a little bit smaller than that one? Yeah. So that works out. So angle bisectors, I would say, is kind of the oddest one of the bunch, and so you might want to make a note of that and deal with those a slightly different way. But all 4 of them we did on the first page, you've now seen an example just like them. Any questions?